Hey everyone, welcome to today's Explainer. We are diving straight into how Dukelake is literally rewriting the rules for modern data lakehouses. If you've ever found yourself losing sleep over agonizingly slow transactions, or that absolute nightmare known as the small file problem during continuous data ingestion, well, you are definitely in the right place. We're going to break down this complex engineering hurdle into something that makes total sense.
Here's our roadmap for today. 1. Meet Dukelake. 2. SAP Open Items. 3. The small file problem. 4. Lightning clearing. 5. Time travel auditing. And 6. Our key advantages summary.
All right, Section 1. Meet Dukelake, a new architecture.
So what exactly is Dukelake? The crucial point here is that it's not just another storage bucket. It's an entirely new open-source analytical table format and catalog specification built by the incredibly smart folks over at DuckDB Labs. And because it's completely open under the MIT license, it offers massive flexibility. But what's really fascinating, what really gets data engineers excited, is how it fundamentally rethinks the modern data stack from the ground up.
You see, Dukelake physically splits the modern lakehouse into two distinct, highly optimized layers. You've got your data layer sitting over in cloud or local object storage, think Amazon S3 or Google Cloud Storage, holding your bulky Parquet files. But then, instead of managing a messy, tangled hierarchy of manifest files for your metadata, Dukelake drops your table definitions, your schemas, and your transactional logs straight into a relational SQL database. We're talking DuckDB, SQLite, or Postgres. It's just a vastly cleaner, smarter way to organize your data's brain, so to speak.
Moving on to Section 2, SAP Open Items Explained, the business context.
To really grasp why this architecture matters, let's look at SAP Accounts Receivable. An open line item is simply a financial record of an unpaid customer invoice. If you live in the SAP world, you know these typically live in tables like BSID or BSEG. Basically, every single time a credit sale happens, one of these records is generated to represent money owed to the business.
Now, when the cash finally hits the bank account, the application has to match that payment to the unpaid invoice. The status officially flips from open to cleared. In SAP, it gets stamped with a clearing document number, the ALLU-GBL, and a clearing date, the ALLU-GDT. And then this newly matched record typically lands in a cleared table like BSAD. Sounds super simple on paper, right? Well, at enterprise scale, this constant, non-stop matching and updating triggers a massive technical headache.
Which brings us to Section 3, the small file problem and its ingestion challenges.
You see, businesses don't just process one giant, convenient batch of invoices at midnight. They process continuous micro-batches all day long. And traditional file-centric lakehouses get completely bogged down by this. They end up creating thousands of exhausting, tiny Parquet and metadata files for every single small write. Over time, your storage system literally chokes on this small file problem. It completely destroys your query performance and drives your cloud compute costs straight through the roof.
And this is exactly where Dukelake steps in with an absolutely brilliant solution called data inlining. Instead of immediately dumping a tiny file into S3 for every update, Dukelake buffers these small invoice records directly inside its SQL catalog, specifically in sap-fi_catalog.db. It just holds them there securely inline. Then, once that buffer hits a specific threshold, it automatically flushes those rows, seamlessly bundling them into one perfectly sized, highly efficient Parquet file in object storage. Just like that, the dreaded small file problem is completely neutralized.
Next up, Section 4, lightning-fast clearing and ACID transactions.
Think about what's actually happening when an invoice changes from open to cleared. In a traditional setup, updating that status means completely rewriting complex manifest file trees all across your cloud storage. It's heavy and prone to failure. But Dukelake says, no, let's just update the indexed relational metadata tables instead. Because a SQL database is practically built for this kind of thing, the conflict windows for optimistic concurrency control shrink dramatically. The result? You get incredibly fast ACID updates, blazing fast transaction commits, and feather-light system retries. It's a total game changer for system performance.
All right, Section 5, time travel auditing. This is really the climax of the story.
Picture this scenario. An auditor knocks on your door and hits your team with this exact high-pressure question. What open line items did customer CUST_8801 have as of mid-March before the payment was posted? In a traditional file-centric system, answering this means agonizingly parsing through layers and layers of historical files. It's slow, it's expensive,
And frankly, it's the kind of query that makes data engineering teams sweat.
But with Dukelake, it's effortless. Because Dukelake maintains an index snapshot history right inside its SQL catalog, you can answer that auditor instantly. Every change, every transaction is naturally logged as a snapshot within that relational metadata brain. You literally just run a standard snapshot-based time travel query. You completely sidestep the heavy, agonizing overhead of dragging your system through old cloud storage files. It is clean, it's fast, and it makes auditing entirely stress-free.
Finally, Section 6, Key Advantages Summary. Let's bring it all together.
If we pull back and look at the big picture, the value Dukelake delivers for SAP analytical workloads is just massive. First up, data inlining handles those small, frequent SAP updates effortlessly without ever creating thousands of tiny Parquet files. Second, the relational metadata catalog lets you clear open items using swift SQL database updates rather than suffering through incredibly slow file traversals. Third, you get true SQL observability, meaning your teams can inspect catalog history and schema changes using the standard SQL they already know. And fourth, it operates completely standalone or embedded, executing in DuckDB without any of those complex, heavy Spark or Java dependencies.
So it really leaves us with one massive question to ponder about the future of our data stacks. Are you going to keep traversing slow, messy file hierarchies? Or are you ready to finally query your history with an organized SQL brain? Dukelake proves that sometimes the absolute best way to manage a data lake is to just give it a relational mind. Thanks so much for joining me for this explainer. I hope you found it as fascinating as I did.